Hey folks, so this is the fifth and final video in this section, section 4.5. So let's go ahead and jump right on in. The rest of these questions are going to be definite integral questions. So all of the questions that we've done so far have been indefinite integrals. And this is the first time that we're going to do definite integrals for this section. All right, so in this first example here, let's let u be the inside, 2x to the fourth power plus 1. The derivative of that is going to be 8x cubed. Now you'll notice that this gives me something to plug in for this piece, and then I also have something to plug in for the x cubed dx, but I don't need the 8, so let's throw the 8 over to the other side by division. All right, so in our substitution then, this guy is going to be our u squared. And then the rest of it, the x cubed dx, is going to get replaced with a 1/8 du. Now you'll notice that I'm not writing the numbers. Notice how over here I'm evaluating from 0 to 1, but that number 0 and that number 1, those are assigned to x values, and because I'm not using x values right this minute, I'm using u values. For the time being, I'm going to ignore that this is a definite integral, and so I'm not going to write any values in there. You just have to make extra sure, be careful that you don't forget about those values when we go back to x's at the end. All right, so let's go ahead and integrate. Leaving the 1/8 alone, our integral is 1/3 u to the third power. I don't need a plus c because this is a definite integral. So at this point, let's clean up the fractions, and then we'll also resubstitute the 2x to the fourth plus 1 back in. So my fraction is going to be 1/24. With my x's in there, that'll be 2x to the fourth plus 1 cubed. And now that I'm back to using x's, I can use my 0 and my 1. Again, those are x values, so that's why I didn't write them in when I had the two lines using u's. All right, let's go ahead then and evaluate. So the 1/24 I'll leave out front, plug the 1 in, plug the 0 in, and subtract. And so when I plug the 1 in, I'm going to get a 27. When I plug the 0 in, I'll just get a 1. So this will be 26/24, which reduces to 13/12. Okay, next example. So the inside is what I'll make u equal to. The derivative is negative 2x. Now it doesn't look like I have any negative 2's, so I don't really need the negative 2 piece. So I'll move that over to the other side. But I do need the x dx piece. All right, so then on the inside, this is going to be a u to the 1/2 power. And then the x dx, that's going to get replaced with a negative 1/2 du. Notice that I'm not writing the 0 and the 1 because those are assigned to x values, and for the time being, I'm using u's. So let's integrate. I have my negative 1/2. My integral is 2/3 u to the 3/2. Now let's plug or change back into x's by substitution. Cleaning up a little bit, I'm going to have a negative 1/3 out front because my 2's will cancel each other. The u is going to become 1 minus x squared again. Don't forget your 3/2 power. And now I'm going to evaluate from 0 to 1. So the negative 1/3 is out front. Let's plug in the 1 for all the x's. Let's plug in the 0 for all the x's, and then subtract in the middle. Evaluating that, that's going to be a negative 1/3 times the quantity 0 minus 1, which is going to be 1/3. All right, next example. So my u will be 2x minus 1. Derivative is 2. I don't need any 2's, so I'm going to get rid of that. That'll be 1/2 du equals dx. Now let's take a look so far. I have something to plug in for the bottom, and I have something to plug in for dx. I do not have anything yet to plug in for x, so this is where I'm going to take what I originally came up with, and let's solve for x. So I'll add 1 to both sides and divide by 2. And now I have something that I can plug in for my x, and it's only written in terms of u. Okay, so let's take this piece at a time. So this guy is going to be a u to the 1/2, but it's going to be written up above, so it's going to be u to the -1/2. And then I have something in for my dx, and remember my dx was equal to 1/2 du. And then lastly, the x that was on top is going to get replaced by a u plus 1 times a half, and that 1/2 can be written out front. So combining the two out front, we'll have a 1/4. Let's go ahead and distribute. So that'll give me a u to the 1/2 plus a u to the -1/2 du. And then we'll integrate. Notice I'm not worrying right now about my 1 and 5. These are x values, and for the time being, I'm working in terms of u. Okay, so we have our 1/4. The integral of u to the 1/2 is 2/3 u to the 3/2. And then the integral of u to the -1/2 is 2u to the 1/2. Let's put our x's back in. Now, in case you're wondering, where did that 1/6 come from? One of the things that I'm doing here is I'm going to go ahead and distribute the 1/4. Okay, so just be aware. So the 1/4 times 2/3, I did a little bit of canceling, and I got 1/6. Plugging my x's back in, plus, remember I'm taking the 1/4 times the 2, so that's going to reduce to a 1/2. Plugging my x's back in, and now I'm going to evaluate from 1 to 5. All right, so this is going to get a little ugly here because I've got a lot of terms to worry about. But I want to take my 5, and I'm going to plug it in for this x and this x. This is going to be all the first big set of brackets. And then after I do that, I'll take the 1 and plug it in for both of those x's. That'll be the second big set of brackets. All right, so let's jump right on in. So I've got my 1/6. There's my 5 plugged in. Here's my plus 1/2. Again, my 5 plugged in. Now we're going to subtract all of the terms with 1 plugged in. So there's the first term with 1 plugged in, and there's the second term with 1 plugged in. Do you notice how I'm working now in square roots instead of fractional powers? And you'll see, I think, why here in just a moment. So this piece, 1/6, no problem there. This guy is going to be 10 minus 1, which is 9, and the square root of 9 is really easy to do mentally. So the square root of 9 is 3, and 3 cubed is what I'm going to be looking at. Same thing with the second term. Square root of 9 is 3, so I'm just going to have a 1/2 times a 3. Minus, so I'm going to have my 1/6. This guy is going to be the square root of 1, because 2 times 1 minus 1 is 1. So the square root of 1, that's really easy. Same thing here. Let's continue to clean those up, combine them all, reduce your fraction, and you'll get 16/3. Make sure that you can work through that math on your own, that you don't need me guiding you to do that. All right, next, let's find the area under the curve. It does say to use a graphing utility to verify your result. You can do that if you want, but you don't have to. All right, so we're looking here at number 70, which is this guy right here. It's a definite integral. So let's use our u first. U will be the inside. Derivative is 1, so du equals dx. And what I see is that I have something to plug in for this, and I have something to plug in for this. Unfortunately, though, I still don't have anything to plug in for this, so I need to go a little further. Let's take our u equation, and let's get x alone. So that'll be u minus 2 is the same thing as x. And now I have something to plug in for this guy. All right, so what you see here in this first line, this is just a rewrite of the original equation. I didn't do any work there. Let's start substituting. So for the inside, let's plug in our u. For the dx, let's plug in our du. And for the x squared, let's plug in our u minus 2, and we're going to square that. Now, we cannot distribute here like we did previously. The first thing we're going to need to do is we need to square our quantity. So just use foiling there. Times u to the 1/3. And now I can distribute to all three of these terms. So distribute, you get u to the 7/3, 4u to the 4/3, 4u to the 1/3 du. I can integrate each of these pieces individually. So the integral of the first piece is going to be 3/10 u to the 10/3. The second piece, -4 times 3/7 u to the 7/3. And the last piece, plus 4 times 3/4 u to the 4/3. So now we're ready to clean up our coefficients, but let's also put our x's back in. So you remember that u is going to get replaced by an x plus 2. All right, so we have 3/10. There's my u to the 10/3. This piece, the coefficient gets cleaned up to 12/7. And the last piece, my coefficient just gets cleaned up to a 3. And now I need to evaluate from -2 to 6. Now you'll see here, I've already got two big brackets. My first bracket is where I plugged in all of my 6's into the x's. And the second big bracket is where I plugged in -2 to all of the x's. So plug in a 6, plug in a 6, plug in a 6. Notice that 6 plus 2 is 8, so that's where I got that. Also notice that I switched back over to roots. And the reason is the cubed root of 8 is really easy to come by. Cubed root of 8 is 2, so I just thought of it as a cubed root instead. Now let's go plug in our -2's. Plug in a -2, plug in a -2, plug in a -2, and each of those terms is just going to equal 0. So I really only have to worry about the first big bracket. Everything in the second big bracket is going to be 0. All right, so this first piece here, this is going to be a 2. 2 to the 10th power is a big number, but you have a calculator. It's going to be 1024. Minus 12/7, 2 to the 7th power is 128. Plus 3 times 2 to the 4th power is 16. So combine all that, you're going to get an ugly fraction of 4752 over 35, which is the same thing as the decimal 135.7714. All right, that's all we have for section 4.5.